Hey, hi, good evening, everyone. Good evening, friends. All right. Okay, we'll discuss on the lines. Okay, so first of all, I hope every one of you have celebrated Christmas well. Right, welcome back to our program range from Python fundamentals to AI. So, in the last class, we have understood the univariate plots. Right, so under the univariate plots, we discussed bar plot, histogram, then box plot. So we'll quickly recap what we have covered in the last class, then we'll jump into the next topic. Right. So as part of CRISP MLQ, a project management methodology, 1 minute, yes, CRISP MLQ, you know, which is a project management methodology for any machine learning or deep learning project. There are 6 phases. In total, we have 6 phases under CRISP MLQ. Under, out of these 6 phases, we are actually, currently we are learning phase two. What is phase two of CRISP MLQ called? Data preparation. Okay. So again, under this data preparation, we have 3 subphases. One is EDA, exploratory data analysis, then data cleaning, and finally feature engineering. So out of again these 3 subphases, we are actually learning EDA. Under EDA, there are 4 moments and data visualization. We'll be visualizing the raw data and we'll try to understand the data. How is the data? Okay. How do we understand the raw data? By performing or by measuring 4 moments. Right? So when we try to complete of these 4 moments, we get a clear picture how the data is. Then we'll try to visualize the data, and under data visualization, there are again of 2 types: univariate and bivariate. Univariate means, you know, taking one column at a time, visualizing one column at a time. Whereas bivariate means trying to visualize 2 columns at a time. Okay, so under univariate, we discussed bar plot, box plot, histogram. So we'll quickly revise. Bar plot. Why should we visualize bar plot, or what is the objective of visualizing bar plot? Bar plot is used to understand data distribution. In order to understand the data distribution, we generally visualize bar plot. But we have a challenge with respect to visualization of bar plot. What is the challenge? The challenge is when you try to visualize bar plot on large data. Okay, when you try to visualize bar plot on large data, instead of instead of getting bars in the plot, you will find lines, and these lines will be very close to each other in such a way that we cannot interpret anything from the plot. Nothing. So, what is the use of visualizing bar plot? So, there is no use, right? At the end of the day, why are we visualizing bar plot? To understand the data, to understand the distribution of data. But does it hold good for all the data, all the types of data? No. Why? The bars that you see gets congested to lines for large data sets. So bar plot is not an ideal plot for understanding data distribution. It's clear. Then how can we understand the data distribution? Which plot helps us to understand the data distribution? If that is the question, histogram comes into the picture. Both are same friends. You see bars in this bar plot. You'll also observe the similar bars in histogram. But what makes the difference is instead of getting bar for each value, in histogram it tries to bin the value. Nothing but it tries to form groups. It creates some bins. See, 20 to 30 is a bin, 30 to 40 is a bin. Bin group, all are same. Okay. So under histogram, the data gets grouped, and depending on the value of that bin, the size is what you observe. So what can I interpret from this histogram is, I observe that there is no, or I should say, the number of people between 80 to 90 years, okay, they are very less in number. They are very less in number because I don't see any bar for this particular bin. Okay, so that is one interpretation that I can make. And additionally, between 50 to 60, the people whose age lie between 50 to 60 are actually more in number. Yeah, these are some, interpretations, understanding that we can draw from the plot. But by looking at the data, can you draw from, the raw data such kind of interpretations? No. So that is the reason we visualize the raw data to get insights. Okay, so and I can clearly see the data with respect to skewness. You have to talk about skewness, kurtosis. All of these, technical words should come into the picture. Whatever we have understood as part of four movements, you have to interpret them with respect to the plots. Alright, so the main objective of visualizing bar plot, sorry, histogram, is data distribution, is to understand the data distribution, and we can also comment on outliers, the extreme values, but we are not sure, friends. Okay, so in order to make a strong decision, in order to make a strong interpretation with respect to extreme values or outliers, so we have the one and only plot called as box plot, also called as whisker plot, also called as box and whisker plot. Right? So box plot is the only plot which visualizes outliers, which visualizes outliers. So that means if a value, if it is greater than upper limit or if it is less than lower limit, then we can call it as an outlier. So this interpretation, you can draw it from a box plot only. Okay, the primary purpose of visualizing box plot is to comment on outliers. Yes. And what about the secondary purpose? To understand the data distribution. How can we understand the data distribution using box plot? As we discussed, both the whiskers should be identical in size. That means both the whiskers should be same in size, and even the boxes as well. Box 1 and box 2. Right? So this is how you are going to interpret each and every plot, and I have asked you to go for hands-on by taking different data sets. Right? So I hope everyone have worked on hands-on, and some people stay struggling with some issues. We'll sort it out, friends. No worries. No worries. We'll do it everything. That's okay. All right. So, what will be the next step? The next step is, so I hope no questions with respect to univariate plots. Right. So as part of univariate plots, we discussed bar plot, histogram, and box plot. And now the question comes with respect to code. Okay, how many of you have tried visualizing bar plot using Python code? It might be on any data set. Did you try at least? Did you try or not? Okay, good. Okay. So how many of you tried? Okay, when you have tried visualizing bar plot, which package did you use? Matplotlib or Cbond? Did you use Matplotlib or Cbond? Matplotlib. Okay. So under Matplotlib, we are not importing the Matplotlib, right? We are importing a sub package of Matplotlib called PyPlot. Okay. So as part of this pie plot, what is the function that we have used to visualize bar plot from pie plot? What function did we use? What is the function name? Is it bar? Yes. So it is nothing but pyplot dot bar, which is the actual function coming from pyplot subpackage, is used for visualizing bar plot. Good. When you try to visualize bar plot using bar function from pyplot, how many arguments, how many parameters did you use inside this bar plot function? How many parameters did we use? Did we use one, two, three, four, or how many? Two. What are they? Height and x. Two. Height and x. Good. What does height take? What values does height take? Height parameter take? The data, whatever the data that you are actually trying to visualize for the bar plot. Okay, so that data has to be passed for height parameter. And what values does x take? Whatever it might be. You need not just focus only on the data set. Whatever might be the data, that data you have to assign for height. Good. What about x, friends? For x, you are supposed to pass sequential numbers. So how can you generate sequential numbers? I can generate using range function or arange function from NumPy. Good. What is the syntax of range function? Arange coming from NumPy package, np.arange. Okay, good. It's not NumPy and arrange. NumPy dot arange. It is a function from NumPy module. Don't get confused. Huh? What is the syntax for range function? Good. Range of start, stop, step. Range of start, stop, step. By default, what is the value for start? By default, what is the value for start? 0. What is the value for step by default? 1. Good. Everything is perfect. When you try to use height and x, these two parameters inside bar, okay, you will get a bar plot on whatever the data that you are trying to use as part of this height parameter. On that values of data, you will visualize a bar plot. Perfect. But my question is, understand properly. My question is, how many of you have ignored x? That means how many of you have tried visualizing bar plot using just height column or height parameter only, where you did not pass x values? Did anyone try that? Where you did not pass x values and just used only height values, nothing but the data? No. Okay. Okay, my friend says error. Will we get error? Sure. For sure, will I get any error or not? Tell me, friends. Will I get any error or will it get executed? I'll get error. So why I'll get error? That is something I want you guys to explore. Okay. So I'll not reveal it now, but yes, that is the error that we'll get actually. Bar function missing one required positional argument x. Good. Right? So I want friends, I want you guys to try uh, you know do hands-on in that way so that you'll understand more. Why are we getting an error? What is the positional argument? What is the positional argument? What is the positional argument? Python videos we have covered. Does it take a range of values? No. Positional argument does not take any range of values. No. See, under arguments, we discuss the types of arguments, right? Positional, keyword, default, variable length, keyword variable length, hands-on. Positional argument are the arguments where the values, the values within the function. For example, bar is my function, right? So within the function, when you pass the values, for example, say 1 comma 2, okay, whatever the argument that is present initially when bar was defined, we'll define bar, right? Bar function. When you define bar, okay, you will use some parameters for defining a function. Yes. So based on the position, the values will be assigned. A will take 1, B will take 2 during the call. So in a similar way, now try to understand bar function missing one required positional argument x. That means, under bar function, you are supposed to pass the values of x for sure. If not, it will throw you an error. Okay, so even still you can do many experiments. Try first, keep the values of x first, then height, and check will it execute or not. What kind of arguments are these called? It will import, my friend. Each and every package gets imported. Why it is importing for me? Why not for you? So think. Okay. So why am I, wasting my time, and why am I giving a clear explanation regarding all these? Is see, we understood each and every concept of Python. Am I right? Yes. But thing is, when you do hands-on, if you get such kind of questions, changing the places of parameters, ignoring one, trying to visualize plot by just passing only one argument, will it execute or not? So when you do such kind of experiments, I should say experiment, you will understand more. You'll understand more instead of just practicing as is. You have to do in this way. When you try to do hands-on in this way, you will learn more, right? So that's up to you, but my humble suggestion will be, you know hands-on. If anyone asks me how can I learn any programming language or whatever it might be, friends, only thing is practice. If there is no hands on, nothing. Because we are not here to watch a movie. Am I right? Are we here to watch any movie? No. If it is a movie, we'll watch for 3 hours, and that's okay, even though if we ignore it. Even though if we are going to lose the concept of this movie, that's fine, it works. But this is something related to our future. Why? Because I'm hearing news that AI is grabbing the attention. Okay, in order to learn AI, what are the steps that I have to do? First one is Python. Okay, what is this Python? Python is a language, programming language. How can I learn Python? Very fast, hands on. Then next to hands-on Python, we have ML. Okay, whatever we are discussing, all of these are basics. EDA, data cleansing, all of these are different topics which are like foundations for AI. If you understand these concepts well, you can, work on an AI project, and this will help you in future, right? Let us start our day. So why we have not installed? Ah, good question now, my friend. Let me go back. How see? Very good question, I should say, because really, when I have asked you to work on Matplotlib, everyone started just importing it. Am I right? Yes, obviously. We'll keep it as import matplotlib. Done. If it executed, that means we have matplotlib in our local machine. So that is the reason it is importing matplotlib from our local machine to the memory. Okay. What if this line of code throws any error? If it is throwing error, that means you don't have matplotlib package in your local machine, then we'll install, right? So just what we have done is we imported. No one of us, I think 100 out of 100, no one will get an error. For all, it will get executed. It gets executed. The reason is matplotlib is available in your local machine, in your system. Matplotlib is available as a folder. Okay, who installed it? Did I install, or who installed it? Yes, question to all of you. Who installed? Did I install in your systems? No, right? Who installed? The thing is, when we tried importing pandas, it executed. When we tried importing NumPy, it executed. So in the same way, we also tried matplotlib, it executed. So that is the reason, I just try to visualize bar plot, box plot, histogram. That's fine. What does that mean? That means matplotlib is already present in your system. But the question is, who installed that in your system? Who installed? No one. Huh. How many of you are using Spider from Anaconda? How many of you have installed Anaconda? Anaconda Navigator, which I have asked you guys to install on day one. Good. Hmm. I asked you guys to install Anaconda Navigator. The reason is this itself contains, it's a community which helps data science people by providing multiple IDEs, integrated development environments. Hmm. Right? So every one of us have installed Anaconda Navigator. So Spider, from where we are launching Spider, I am launching Spider from Anaconda Navigator. Yes. So what happens is, when we try to install Anaconda Navigator, what is the process? Initially, I have to download a .exe file of Anaconda Navigator. So this will be around 1 GB, right? So this will be around 1 GB. What happens is, when you try to install Anaconda Navigator after downloading this file, in the process, that process itself, in the back end, all the important widely used packages will be installed. Now, whatever it might be, friend, okay, whatever it might be, either it might be Jupyter, Spider, or say PyCharm, Orange, RStudio, whatever it might be, in the back end, all of these are nothing but the IDEs of Anaconda only, right? So in the back end, the widely used libraries, packages like NumPy, Pandas, Matplotlib, Seaborn, all of these will be installed. So that is the reason I'm not installing Matplotlib again. What is the use? I have it in my system. So I'm just importing it. So when you try to use, so this particular, doubt, I thought of explaining at the last, but anyways, see, I see majority of you are also using Jupyter IDE, right? So especially when we are trying to use Jupyter Notebook, okay, along with Jupyter Notebook, we also have Google Colab. That it is also one more IDE which where you'll be writing your code in the form of notebook. It will provide you a notebook UI, friends. So in a notebook, in our school days, we used some kind of rule notebook, right? In the same way, the UI will be similar to that. You will have something like this rectangle boxes. In the box, you are supposed to write the code. Okay, when you try to execute this code, down to the box, you'll get the output. But you'll not find the same UI with respect to Spider. Okay, so when you use Spider, you'll get .py script. The extension of the script will be .py. It's a Python file. But when you use IDEs such like Jupyter Notebook, Google Colab, it provides you the script in the format of .ipynb, IPython notebooks. Okay, so it's a notebook. So don't try to open this IPynb script in Spider. It does not support. And in the same way, .py in Jupyter Notebook. That doesn't mean it does not support. It opens, but the code will not be given as is. It will also give the code for the cells. So there will be a lot of mess. So don't try to do that. Just use the notebooks as is. Depending on the format of your file, use the right IDE. Is it clear? Yes. So, but my suggestion will be if you are a fresher, if you are new to Python, if you are new to programming languages, this will be the right IDE. So better use Spider friends, because initially when we are a kid, will we start running immediately? No, right? We'll initially know how to first walk, then we'll start running. In the same way, why am I asking you to use Spider is, the way of understanding the with respect to Spider is completely different. No other IDE is going to provide such kind of features. So again, if you are habituated of using Jupyter, I'm not stopping you, but this is what my advice is. Yes, that's what. So if you are new to programming languages, because nowadays everyone everyone across the globe, whatever might be their domain, whatever might be their history, they started learning AI. But in order to learn AI, first of all, you have to learn some pillars. One of the pillar is Python. Okay, for example, let me take a person who is coming from commerce arts background. What does he or she know about Python? Nothing, right? So what they do, they'll start learning it. But instead of using Jupyter, if they use Spider, not only Jupyter, it might be any other IDE, there is no use. My sincere advice for such kind of people will be Spider. Okay, so don't might be depending on your well-wisher advices. Don't try to use any other IDE if you are new to these programming languages. Go on with respect to Python, then it's up to you. Because again, I'm telling you, friends, no one uses Spider in the real world. Okay, when you come into the real world, into the job market, no one uses this IDE. This is just to understand, to learn. Okay, everyone, majority of the companies, they use Visual Studio, VS Code, if not Jupyter Notebooks, PyCharm. Okay, so these kind of IDs will be used, but for a beginner, it is Spider. Yes. So I hope it's clear the doubt with respect to the matplotlib. Why haven't we installed matplotlib, but why it is importing into the memory? It's clear, right? because as we discussed, by default it will try to import, sorry, it will install all these packages in the backend. Right. Now, before I continue, you know, try to import SQL Alchemy, or okay, let me, yes, try to execute this line, friends, in your systems. Try to import SQL Alchemy in the same, same case. Import in lowercase, SQLA, the first four characters of SQL Alchemy in uppercase, and followed by the rest of the characters in lowercase. Try to import this, open Spider or whatever ID might be, open it and execute. What you are getting, please let me know in the chat. What do you get? Is it executing? Yes. You'll get an error. Module not found error is what we observe. Am I right? Yes. So I hope it's clear. Now, my friend's doubt got completely cleared, because that's what I'm telling. Not each and every package, each and every module, you know, uh, presenting Python is available in your systems. As I discussed, as we have discussed, only a few widely used packages will be installed, when we try to download Anaconda Navigator. So in that process itself, all these important widely used packages, modules will be installed. So a few modules like, see, this is one example. SQL Alchemy is a module, it's a package which is used for, connecting database with Python. Let us not go into this, but since majority of our friends have a question, so does it mean that is it possible to import any package? No. Whatever is present in your environment, only those get imported. Okay? Is it clear now? For one of our friend, it got executed. That means yes. For you, it is installed. Might be you have installed it in right. So this is the process, and what are we supposed to do? If you got a module not found error, what we are supposed to do? Should we ignore the code? What are we supposed to do if we get a module not found error? What does that mean? It is clearly telling us no module name SQL Alchemy. We are supposed to install it. Good. But how should we install it? Using pip tool or conda tool. Pip or conda. So the syntax is pip install module name or conda install module name. Right? So should we, okay, let me keep it here. Akhil told it is pip install module name, and I'll keep it as pip install SQL Alchemy. Okay, so Akhil clearly told me that the syntax is pip install module name. My module name is nothing but SQL Alchemy. So I'll execute this. This is what Akhil have told me. No, friends, I did not tell you this. I have clearly told whenever you are trying to install any module in future, okay, don't do in this fashion. This is not the right approach. What are we supposed to do? What are we supposed to do? What is the process? How should we install a module name, a module? What is the best practice? Yes, you have to visit .pypi repository. You have to visit .py repository and then install. Good. Okay, so open a browser and type SQL Alchemy space pypi. So when you click on enter, you'll get the links. Okay, look for the pypi repository link. Click on that link. Then it will take to another page, and that is where you'll find the repository for pypi.org of SQL Alchemy. Okay, so once if you got this, you'll get the command also. Why should we do in that fashion? Why not directly using the syntax? I directly use the syntax pip install SQL Alchemy, which is in lowercase. Is this accepted? Is it accepted or not? No. Why? Why it is not accepted? Okay, let me show you properly. So assume that I don't have SQL Alchemy in my local system. Okay, so as an example, I'm telling you guys. Okay, so SQL Alchemy space pypi is what I have to type. Then click on enter. See, you see pypi.org. So this is the repository page for SQL Alchemy. Let me click on this. So here you will find the complete information with respect to the package, what it is doing and all. Why should we do in this process? Why not, using the command directly is, look here. Python is case sensitive? Yes. What generally we'll keep it as pip install SQL Alchemy, each and every character in lowercase. But what is the actual case of SQL A? It is in uppercase. Who is going to tell you this? Will someone come and tell, hey friend, you have kept all these characters in lowercase, but only these four should be in uppercase? Is someone going to come and tell us? No. No one is going to come and tell us. You'll get complete, when you try to execute that command, you'll get errors. When you get error, you'll again start thinking, yeah, I have used the right syntax, and why am I getting error? Because Python is case sensitive and it does not execute that command. So from here, you copy that command, go to the IDE, keep it in the console or whatever it might be, depending on the IDE I'm telling you friends, click on enter. Immediately it starts executing. See, it starts executing and it will install this package. See, as I have it in my system, I'll get a requirement already satisfied message. I already have it in my system and this is my location. SQL Alchemy is in this location. Okay, and what is the version of that particular module is 1.4.25 in my case. What is the current version? 2.0.36. This is the version of the package, nothing but the module. Okay, so even though if I'm, it's wasting my time, but why am I keeping it very clear is because of the case We'll observe n number of issues in Python. To be frank, because of just case, we'll observe, errors. So be very careful with respect to the case. Right. So any questions? Shall we continue? I hope it's clear, right? So what is the next topic? You know, the next topic that we have with respect to, the program is bivariate visualizations. It is bivariate visualizations. So far we have understood univariate visualizations. Univariate are done. Okay, so we are working on one column at a time. This is done. Now comes bivariate visualizations into the picture. What is this bivariate visualization? Nothing but taking two columns at a time. We'll take two column data and we'll visualize the data which is present in these two columns at a time. Okay. So what is the plot that is present under bivariate? Under univariate, what are the plots? Bar plot, box plot, histogram. Are these only the three univariate plots available? No, there are n number of univariate plots, friend. Okay, but we are learning this in order to understand the properties of the data distribution, and the outliers. We are just learning only three important plots under univariate. Okay, but under bivariate, we have only one plot, one visualization called as scatter plot. It is called as scatter plot. Yes. Scatter plot is an example for bivariate visualization. Good. How come? Because under scatter plot, you have to take two columns. One column on x-axis, one column data on y-axis. So since you are trying to visualize two column data, it is an example of bivariate visualization. Oh, so Akhil, you mean all of these are scatter plots? Yes, yes, my friend. Since I'm going to visualize the data on a 2D plane, two-dimensional plane, one dimension is x-axis and the other one is y-axis. X, Y, X, Y. In the same way, it is the same for rest of the plots as well. All of these are scatter plots, but I see different names. Why we'll understand the types and all we'll understand. First of all, scatter plot is a bivariate visualization. But what is the purpose of visualizing scatter plot is it talks about the relationship between two columns. Okay, it talks about the relationship between the two columns. Because you are trying to take one column data on x-axis and one column data on y-axis. So what is the relation between x and y? Okay, that relation you can understand by visualizing scatter plot. Okay, clear. Scatter plot tries to, it gives you the information about three main things, friends. The first one is, okay, I'll add it here. The first one is linearity. Okay, what is this linearity? We'll understand. No issues. The second one is direction. Okay, direction means it's talking about right, left, something like that. Ah, yes. Okay, so second one that scatter plot tells us is direction. And the third one that scatter plot explains is strength. Okay, linearity, direction, strength. Right? So now we'll understand one by one. Linearity. So for example, I take a data, right? Whatever the data might be, okay, let me take the first plot. Okay, so on x-axis, I'll take preparation time. Okay, and on y-axis, I'll take marks obtained with respect to subject. Okay, so how much time did I invest for each subject preparation time, and how many marks did I score with respect to each subject? So this is what I'm taking, and I'm trying to understand the relationship between preparation time and marks. Good. So what will be the you know basic relationship in general? If you study, if you spend more hours, if you invest more time on a subject, will you get less marks or will you get more marks? Obviously, I'll get more marks, Akhil. Yes, preparation time is directly proportional to your marks. Obvious. So it is directly proportional to marks. So in a subject, I just invested only 2 hours. I scored 40. But this is my favorite subject, okay, and I don't want to lose my marks. This is the place where I want to score more, and I have invested more time, say probably 8 hours. I scored 99. See how the relation is. Okay, so I can clearly see preparation time is directly proportional to marks. Investing more time, I'll get more marks. Investing less time, I'll get less marks. Right? So these points that you see are nothing but scatter. Okay? So this scatter, when you try to combine this scatter, you're getting some kind of shape, right? Is it linear or not? Yes. I see a linear straight line. So that is what understood by linearity. Under linearity, we have again two things: linear, non-linear. So this is completely linear. But if you see this with respect to the scatter, is it linear? No, it's non-linear. I'm getting some kind of curves when I try to, combine all of these. Right. Then now let us talk about direction. So what kind of direction can you understand? Again, direction is of three types. Direction is again classified into three types: upward direction, downward direction, and no direction. So what kind of direction you see here? I see an upward direction. So as my preparation time increases, my marks is also increasing. So what kind of direction you see? Upward direction. Right? So upward direction is nothing but positive. Okay, then you come here. Okay, so this is where you observe the downward direction. As the x variable is increasing, what's happening to the y variable? Decreasing, it's not increasing. So this is an example for downward direction, negative. And in some cases, if there is no kind of relation between the x and y variables, you will find no direction. Here there is no direction. If you try to understand the plot properly, I can't understand. See what kind of direction it is. There is no direction. Right? 1 minute. So this is with respect to the direction. Now comes strength. This is very important. Why? Because strength talks about the scatter, the spread. How close is the scatter? Is it very close to each other or it is separated more? That is what you observe with respect to strength. If you see the scatter spread very close to each other, okay, that means, you know, you can tell it's a highly correlated. There is a strong relationship between the scatter, the variables. What if the scatter is, you know, it is separated with some, distance like plot 2? Can I say it as moderate? Because I don't see the scatter is very close to each other, but still they are close. Fine. What if it is the scatter is widely distributed? Weak, strong, moderate, weak. But the question is, for me, this is strong, but for you, it might be moderate. Who is right and who is wrong? No one is there, right? See, I cannot tell with respect to my perspective, okay, in my perception, I'll say this is strong, but you guys will tell me, no, okay, the scatter, the spread with respect to the scatter seems like they are bit, far, not that much close, like, when I compare with plot one, you know plot to scatter is not that much close, and for me it is moderate, is what you people will argue with me. But I say no, 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 it's strong, the strength is strong. So he is correct, who is wrong? Both of us are correct. But how can, for one single plot, how come two strengths will be there? In general, strength is subjective, friends. So this subjective thing will change from person to person, right? In my perception, it is strong, but in your perception, it is moderate. Who is right? Both of us are right. So, in order to make it objective, if it is subjective, every person will have their own decision. But in order to make it objective, in order to calculate the strength, they have come up with small r. They have come up with small r. This small r is called as correlation coefficient. Correlation coefficient. And what is the range of small r? The range of small r is -1 to +1. Okay. What is the magnitude of r? If I take only magnitude of r, it will be 0 to 1. Don't get confused. This is range, this is magnitude. Okay, what does this minus and plus indicating? Minus and plus is indicating direction, my friend. If you get, minus value for r, that means the direction between the variables is in downward direction. See. Whereas if you get a positive value for your r, small r, obviously the direction will be upward. Okay, now the question is, so Akhil, this is perfect since it is subjective, strength is subjective, and in order to make it objective, we are calculating small r, and this small r range is -1 to +1. But based on these values, how do you fix strength? You know, r greater than 0.85. Okay, I should tell mod of r. If it is greater than 0.85, then the strength is strong. Okay, what if R lies between 0.85 till 0.4? This is called as moderate relationship between the variables. Finally, R less than zero point 0.4. It is nothing but weak. If R is less than zero point 0.4, you can say it as weak strength. The strength between X variable and Y variable is weak. Since it is positive, you'll get, but still you'll observe a upward direction with respect to the scatter. If it is negative -0.3, you will find a downward direction, scatter. The scatter will be in the downward direction. Right? What if R is 0? There is no kind of relationship between X and Y. Both of them are independent variables. Okay, so this is actually scatter plot is actually capturing the dependency. Is there any kind of relationship between the variables or not? If there is a relationship, so we'll just calculate the small r and get the small r. Based on the smaller value, we'll interpret how the scatter plot looks like. Clear? Yes. Now let us, these are the different types, friends. There is nothing, something new in this. I'm just trying to visualize scatter plot by taking different values of small r. Okay, so the range of small r is between -1 to +1. R less than zero point 0.4 is weak. The relation between, the strength between the variables is weak. R lying between 0.85 to zero point 0.4 is moderate. The relation is moderate. R greater than 0.85, we say the strength is strong. Okay, let me repeat it. I'll come from scratch. Under data visualization, we also have bivariate visualizations. Bivariate visualization is nothing but visualizing two column data at a time by two. So under bivariate visualizations, we have only one plot. It is called as scatter plot. Okay, so under scatter plot, you'll take one column data on x-axis and one column data on y-axis. Done. What is the purpose of scatter plot? Scatter plot is used to understand the relationship between x and y variables. Whatever the two variables, whatever the two features that you are actually trying to study, okay, it will tell you the relation between those two variables, those two column data. Okay, so what are we trying to understand with respect to the scatter plot is three things. The first one is linearity, second one is direction, third one is strength. Okay, so first one, linearity. So this linearity is again classified into two types, linear, non-linear. Either you observe a linear straight line or you observe any non-linear shapes with respect to the scatter. This is called as scatter, friends. So when you try to combine the scatter, are you observing any straight line or any kind of non-linear shapes? Done. Then comes direction. Direction is of again three types: positive, negative, and no direction. So when do you say that we have upward direction? When the values of x-axis is getting increased, y-axis values will also increase. That is where you observe a positive direction, because you'll observe a upward direction. As x values increase, y values also tend to increase. This is nothing but positive direction or upward direction. In the same way, negative direction. As x value increases, y values start to decrease. So this is where you observe negative direction with respect to the scatter. And in some cases where there is no kind of relation between the variables, the columns, you will not understand the direction. When you try to, combine the scatter, there is no direction here. See, is this the direction? No. Is this the direction? No. Is this the direction? No. So there is no direction. Okay. So this is what we observe with respect to direction. Then comes strength. Strength talks about your scatter spread. How is the spread with respect to the scatter? Is the scatter very close to each other, or are they separated bit far each other, or they are there is the scatter is completely spread with respect to the plot, like this case? You are trying to understand in that way. But the strength is subjective in nature. The reason is, if the scatter is very close to each other, we can say that the variables are strongly correlated. But how can you fix it? The question is, how do you say, or is there any threshold that when can you tell that the scatter is very close to each other? So that being a subjective thing, you know, each one can take their own call. Everyone can come up with their own decision. Strength is again classified into three types: strong relationship, moderate relationship, weak relationship. But this being subjective, we go and calculate a measure called correlation coefficient, small r. And the range of small r is -1 to +1. So nothing but -1, so on, 0, so on, 1. So when I apply mod on these values, what will I get? So the magnitude is 0 to 1, but the range is -1 to +1. Don't get confused. Okay, so this is what we understood with respect to scatter plot. R greater than 0.85, we say that the two variables have strong correlationship. R lying between 0.85 to zero point 0.4, we say it is moderate kind of relationship. R less than 0.4, weak relationship between the variables. Okay, so now it's clear, right? Now let us go and perform hands-on. So in order to perform hands-on, I'm importing the data again. Pandas as PD, which is used for data manipulation. Then I don't think NumPy is required today, but still let me import it. For numerical calculations, Matplotlib for data visualization, and Seaborn for data visualization. What is the difference between Matplotlib and Seaborn, friends? Yes, friend. See, depending on the value of R, we are quantifying the relationship. That's what I'm telling, right? If you get the R calculated, can't you talk about the strength? Is it not possible to talk about the strength? Yes. See, depending on the value of R, I comment the strength. That is the reason I'm No, calculating smaller. Why am I calculating? The reason is in order to ignore the subjective decision, I am calculating a measure called smaller, then I am proceeding. Yes. So Seaborn and Matplotlib both are for visualization only. Matplotlib is a basic, it's a not basic one, basic package for data visualization, whereas Seaborn is an advanced package for data visualization. Okay, basic and advanced, good. Right, let me also load the data. I'm reading the data from a CSV file and I'm storing in an data frame. So I'll not I'll not execute all these lines of code. Let me jump into scatter plot, the plot that we have over here. Before that, I think 1 minute. Yes. Right, friends. Let us go and visualize scatter plot. So scatter plot, in order to visualize scatter plot, we need a function, right? So that function is nothing but scatter, and which is present in the same subpackage pyplot. So as I am referring subpackage pyplot with PLT, I'm using the same alias name PLT dot scatter, which is a function, and within the function I'm passing the arguments, the parameters. X is equals to petal length. So for x-axis, I am passing petal length values, and for y-axis, I am passing petal width values. Okay, and the color. Okay, let me do one thing. I'll remove this color also for now. Now let me execute only this line number 44 and see the output. Come on, friends. What do you comment here? Do you observe a positive, I mean, upward direction or downward direction? Clusters are formed. Good. This is an additional point that we get from scatter plot. Scatter plot helps us in recognizing clusters. Good. I clearly observe an upward direction. See, as the values of x are increasing, what's happening to the values of y? They are also increasing. Let me keep it over here. What is the direction? I clearly see it's a upward direction. Let me increase it. See, it's upward, right? So one of my friend, she gave me a very good, you know, answer. Scatter plot, apart from relationship, apart from relationship, scatter plot also talks about clusters. What are clusters? Clusters are nothing but groups. Oh, Akhil, you mean groups? Yes. So this is group 1, this is cluster 1, and together this will be cluster 2. So it is clear that we can make this data into 2 clusters. Okay, so that is what scatter plot is talking here with respect to this data set. Okay, so with respect to the relationship, yes, I see a linearity with respect to the scatter. And what about the strength, friends? Can you comment on strength? Strength. What do you say on strength? Do you say it as, you know, strong? Is the scatter very close enough? Okay, how many of you say strong? Hmm. Is the scatter very close to each other? Ah. For me, it is moderate because I don't see the scatter very close to each other. But with as with respect to my or in my point of view, the strength will be moderate between petal length and petal width. So what I'm doing is I'm enhancing this plot. How am I enhancing? I'm just, let me, yes. By default, it gave me, blue color scatter, right? So I'm changing the color to green. And for this entire scatter, I'm also adding a few more additional customizations. For x-axis label, I'm passing it as petal length. For y-axis label, I'm passing petal width. And I'm also making a figure of size 10 by 8. And the title, I want to keep it as correlation between petal length and petal width. And finally, using show function, I'm going to run this entire No, I want to display the scatter plot. See, the plot is same, the visualization is same, but coming up with new customizations. Title, this is my title. Y-axis label, X-axis label, and it is very clear. In previous plot, we got the scatter in blue color. Now I see the scatter in green color. Okay, so majority of our friends says blue, sorry, moderate. The strength is moderate, but let us also prove it. How can we prove it, friends? How can we take a call with respect to you know uh, the strength? How can we take a call with respect to the strength? How can we focus on the concept? How can we comment or how can we get the information regarding the strength irrespective of the plot? How can I get the value? I'll just calculate r friends, small r. For that, we have a function called, let me use it, iris underscore data is the actual data frame, and the function is CORR. Nothing but correlation coefficient is the function. When I execute this, I'll get the square matrix. What is a square matrix? What is a square matrix? Square matrix is a matrix in which number of columns and the number of rows will be same. So, depending on the number of columns that you have, how many columns I have? 5 columns. But I see only a 4 by 4 matrix. The reason is, out of these 5 columns, only 4 are numeric and one column is non-numeric. And how can correlation coefficient be calculated for non-numeric column? So you'll observe only a 4 by 4 matrix. Akhil, how to interpret these values? Simply ignore the diagonal. See, towards the rows, I have all the columns, and on the columns also I have columns only. The same column, sepal length, sepal width, petal length, petal width, petal width. Okay, so ignore the diagonal. Why? Because the diagonal values will be 1. Why it is 1? The same column with the same column. Sepal length with sepal length. Obviously, the correlation will be high. 1. With petal length with petal width. Okay, so since the columns are same, obviously the diagonal values will be 1. Ignore it. Either you consider the lower triangle or upper triangle. Any one. What are the columns that I took? Petal length, petal width. Petal length, petal width. So let us check with the relation between petal length and petal width. Petal length, petal width. See the relation. We assume it as moderate, but what does R tell? R is saying that it is 0.96, which means, what does it mean? Strong. Now it's clear. So, strength being subjective, every one of us will come with their own decision, own answer, right? In order to quantify it, we have a measure called correlation coefficient, and this correlation coefficient is actually giving you the output. A number is given which lies between -1 to +1. What does the direction indicate? Minus and plus is indicating the direction, whereas the values indicate the strength. Since the value is greater than 0.85, so we can comment that the strength is strong. And what kind of direction? Upward direction. In the same way, tell me the relationship between sepal length and sepal width. What is the correlation coefficient value between sepal length and sepal width? Sepal length, sepal width. Is it strong? Don't get confused. Sepal length, sepal width. Where is it? This is the value. What is the direction? Negative direction, this way. And what is the value? It is less than zero point 0.4. So obviously weak relationship. There is no relation between sepal length and sepal width. Don't get confused. Okay. Tell me the relation between petal length, sepal length. Petal length, sepal length. Petal length, sepal length. What is the relationship? It is strong. Good. And what is the direction? Positive. See, positive direction, nothing but upward direction, and greater than 0.85. So there is a relation between, a strong relation between sepal length and petal length also. Okay, so when we observe properly, sepal length and petal width and petal length, both of them have strong relationship. Right. So any questions for the day? If no questions, friends, tomorrow we are going to start a new topic called data cleansing. And this is very important. Even though if you are ignoring till today, that's fine. But if you at least start listening to the classes from tomorrow, you know, you can grab some knowledge because these can be done as your real-time projects. Okay, how to clean data? What are the different steps available? There are in total 9 steps. So all these 9 steps we are going to learn. But this is very important. Okay, it takes time, friends. Don't ask such kind of questions. See, the only thing is we are doing these sessions for your knowledge. We want to show that we are technically good enough, we are strong enough, and use these sessions in a right way, proper way. Okay, don't just give your feedback and leave. That's not the right process. Okay, let me take up your questions. Value error raised for Setosa. 1 minute. For which line did you get that error, my friend? Did you get that error for this line? When you are trying to calculate correlation coefficient matrix, you are getting an error. Yeah, yes. See, we can also comment the presence of outliers, but not sure. Similar like histogram, using scatter plot also we can comment in a sense. This particular value might be an outlier, but we are not sure. The only plot that is, with 100% confidence you can comment is box plot. See, if you are getting such kind of errors, only thing is, check with your proper column name. If you don't give the column name properly, it will throw you error. So what you'll do is, you better change the column names. I have changed the column name. See, if you see here, I changed my column name to sepal underscore length. That's what. Change the column name. Don't use that same column name. Better change it. Sepal length, sepal width, petal length. Then try. It has to give you the correlation coefficient matrix, but why it is not executing? I need to check. The reason is, uh, did you type the same code correlation data frame dot corr function? Okay. Even still you can do that, my friend. When you are calculating correlation coefficient matrix, you ignore that variety column. How can you do that? Pass only the first 4 columns. How can you do that? How you can do that? Tell me. We discussed in this topic. We discussed in Python. Sorry, in Python module. We discussed this. You are asking me. Okay, that's what. How can we do that? Think on a data frame. See, this is a data frame, right? How can we consider only a subset of data frame? Do you remember the concept of ILOC? No? You try this and tell me, is it working or not? Right? Yes, ILOC, LOC we discussed, right? Using ILOC, we can do that. We can achieve the output. Okay? Then the person who is actually getting the error with respect to the plot, what you can do is, uh, Once also check your column name, is it petal length set cm or only petal length? Check properly. The error that you are getting says there is no column with that name. Okay, so if there is no such kind of name and if you are trying to do that, it will throw you error. So my humble suggestion will be better change the column names, rename it using Python itself. We discussed rename function, right? So using that logic rename function, you rename the function to this way, sepal underscore length, sepal underscore width. In this way, if you do it, it will be very easy when you try to visualize. But before you do that, check your column names properly, feature names properly. So do one thing, change the column name, rename it. Rename to any other name where which can be used in future. Give an appropriate name, then it will work. For sure, it will work. The problem is not with the code. The error that you're getting is with respect to the column names. Right? Anything else, friend? See, I'll tell you one thing, but it's up to you again. When you get more number of errors, that means you are developing. Okay, when you develop, obviously you'll get errors, and you'll also, gain, or first of all, you gain confidence how to tackle problems in real world. Okay, that you are learning from your learning stage itself. So don't put everything in my plate. Okay, you start doing on your own. If you are still facing the error or if you are still facing the issue, then come to me. For sure, I'm going to help you. But what is the use if I tell you immediately? So spend some good enough time on that and then approach me. But if you learn something on yourself, whatever you do, self-learning or whatever the problems that you're going to deal on your own, you will be carrying till your last minute. But if I give you the answer now itself, that might be you will be remembering for a couple of days, might be a week or month, then you lose it. It doesn't, make any sense. And from today, it's better. I am also going to give one suggestion for you, friends. Okay, this is just like a suggestion that I generally give to my students. Okay, so it's like a suggestion only. So all of you guys were, attending the classes on daily basis, and I know majority of you are very sincere, towards your future. You have lot of goals, right? So what you can do is, on daily basis, you are attending the classes. Am I right? Yes. Now let us do one thing. From today onwards, we'll implement this. Everyone, when you are doing hands-on, okay, with respect to Python, you will get errors, right? In general, this is the process. Obviously, we'll get errors. Yes. So these errors, for all these errors, I want you guys to maintain one separate Excel sheet. Maintain one separate Excel sheet for only these errors, in the way that in the first column, keep the error. Copy the error from the console and paste it in the Excel sheet. In the column B of your Excel sheet, provide the solution for your error. What is the solution that you have implemented to get rid of this error? Keep it in your column B and save all these errors. Maintain a track record. Okay, keep a track of all these errors. Why? Because you know, we are 100% sure that the error that you get once might be repeated for n number of times in future as well. Okay, so when you get the same error time again, you will implement the solution, right? Obviously, this error gets sorted within seconds or minutes. But sometimes, even though if you give this solution for the error, it will not get solved. Then you'll find one more solution. Add that solution in column C. So in this way, you have to develop this Excel sheet. This is nothing but log sheet for your errors. Nothing but error log sheet. This is very, very important, friends. The reason is majority of my students got success because of this sheet. They have, I mean, in future, this is going to help them. They got, better opportunities. They were in a great position now. So I'm actually requesting you the same, yes. So that is what, but it's a request only. If you want to do it, implement that, obviously you'll taste this success. But tasting again, it's of two types: more, less. So this is going to give you more success. Simple. That's it. In simple, more success is what you will be achieving. And yep, I hope your questions are solved for the day. Let us not drag it. I'll conclude the session here. We'll meet tomorrow, and you know we'll continue with the next topic. Thank you so much, friends, for joining today. And if you feel these sessions are really great, before you leave, just hit on the like button. If you are facing any kind of issues with respect to the hands-on, one of our friend is daily commenting her issues in the comment section. In the same way, I request everyone to comment if you have any kind of questions. If you have any kind of issues, use the comment section. We'll provide you the solutions. So that's all for the day. We'll meet tomorrow. Have a great day. Signing off. Bye.